All right. Hey guys. I know this is a little bit unusual versus our normal class, but unfortunately, I am going to be out of the country for Thanksgiving break and I will not be flying back until Monday night. And so obviously, I cannot teach our regular lecture on December 2nd. So this is what I'm going to be doing instead. I hope that you guys have at least listened to me in lecture enough to know that we will not be having class on December 2nd. However, this is the exchange point. So this is what we're doing instead. This will hopefully be a super short lecture, um, maybe 45 minutes. But I'm gonna throw in some pauses for you guys to do some practice problems and work through some stuff on your own. So you're gonna have to do that. Um, to show that you have watched this entire video, there will be two questions split halfway through the lecture. Where you guys will have to give me that answer on Wednesday, December 4th. So that's the deal. You guys need to watch this video in its entirety. You need to give me the two answers to those questions on Wednesday. Um, and in exchange for that, you guys do not have to come to chemistry on Monday. So watch this at home. If you show up to the classroom, nobody will be there. So please head over to Activity Hall and sign in or hang up or go back home. Because I know that some of you, this is your only class, and some of you don't have classes until the afternoon, so please do not show up to UTSA on Monday for class. Please stay home, watch this, take a little bit of an extra break for Thanksgiving, and we will see you on Wednesday. So, two other really quick announcements. Um, the first one is that experiment 7.1, um, the lab sheet, if you did not finish that in class, that will be due on Wednesday, since obviously we're not going to be in class on Monday to collect it, which also means that your test 7 is due on Wednesday, not Monday anymore. So no matter what that test says, it is due on Wednesday, and I will grab those from you then. So all right, let's get into the lecture. So we are starting Module 8, and Module 8 is all about this big word, stoichiometry. And stoichiometry is a big crazy word, but pretty much all it is um, okay. Oh, good. You guys can see that in the recording. Stoichiometry is relating quantities of substances based on the number of moles or their molar amount. I'm gonna grab a new marker. Let's see if any of these will better. Okay. Turns out I have the best marker in the room already. So, um, stoichiometry. We've already talked a little bit about this. You guys know just a few basic introductions to it. How do we calculate the number of moles that are needed? And what we're going to do is we're going to use those full balanced equations. So we talked about this with the combustion of methane. So CH4 plus O2 will yield CO2 plus H2O. If you guys look at this, this is not a balanced equation. So let's go ahead and balance that right now. So CH and O, CHO. See if you can pause this, balance it on your own. I'm going to keep going. and just balance it for you. And so then check up back with me once I'm done, see if you got the same answer. So 1 over here, 1 there, 4, only 2 on this side, 2 oxygens, but 3 over here. So I'm going to double that and double that. And so now we have our full balanced equation. And if you guys remember, these coefficients are also the number of moles needed in the reaction. So I'm just going to erase this part. With this, 1 molecule of methane will react with 2 molecules of oxygen to produce 1 molecule of carbon dioxide and 2 molecules of water. So if we bump that up, 6.02 times 10 to the 23rd molecules of CH4 will produce 6.02 times 10 to the 23rd molecules of carbon dioxide. So 1 mole will produce 1 mole over here. 1 mole and 2 moles produce 1 mole and 2 moles. So those coefficients are also the number of moles needed to react. And we are going to use this a lot in chemistry, figuring out how many moles are needed in the reaction versus how many do we have, and what can we do with that. So what we're going to start with is we're actually going to go back to algebra and give you guys a little bit of a concept of like how to solve for like X and Y. Obviously, you guys would know y equals X plus 7, let's just say. You guys know you could rearrange this. You could do X is going to be equal to Y minus 7, and you could then figure out what the quantities are based off of what you're given. So if we know Y is equal to X plus 7, if X is 4, we know that Y will be 11. But if we're given Y, let's say Y is 4, now we know that X is going to be, I'll actually write that out. Now let's say Y is equal to 4. Now we know X is going to be equal to -3, like that. And so I want you guys to keep that in mind as we are talking about these quantities with moles, because they're actually related and very similar like that. So math equations, chemical equations, think of it in the same way. So let's start off with a first problem. I'm going to walk us through, really simple, and then we'll get into some hopefully deeper stuff. So, okay, let's erase this. Okay. So in this reaction, we are going to use NH3 plus H2SO4, and we are going to produce NH4 to SO4. Obviously, that is not balanced. We see that we have more nitrogens on one side and more hydrogens, and so we're going to go ahead and start just by balancing that reaction. So how we're going to do that? We're going to leave SO4 as its own group because we see SO4 stays here and there. And so I'm going to start on this side. I'm going to try to balance those nitrogens first. And let's see what happens. So 6, 8, Oh, and then turns out that that balances actually our entire reaction just by adding that 2. And so now we have coefficients of 2, 1, and 1. And so you guys know that 2 moles of NH3 plus 1 mole of H2SO4 is going to equal 1 mole of NH4 2SO4, like that. Which, think back, that's exactly our x plus 7 equals y, or was that the equation? X minus 7? Whatever the equation is that I gave you, that is basically what we're doing. So we've got x, y, and z and different coefficients in front, and so we can solve for the other things. So now, I don't think I gave you the full question, but what ends up getting produced is 12.2 moles of ammonium sulfate. So we produce 12.2 moles of our product. How many moles of ammonia do we start with? And so actually, we don't have to look at the moles of sulfuric acid at all. We can just look at NH3 and NH42SO4. And so 2 moles of this is going to give us 1 mole of that. And so you guys know, we've done this before in class, we're going to use a little conversion factor. So 12.2 moles of NH4, whoops, parentheses wrong, NH42SO4, and that ratio is 1 mole of NH4 to SO4, and then we put 2 moles NH3 on the top like that. And so moles of NH42SO4 cancel out. And so then we just will multiply this across and get 24.4 moles of NH3. And that would be our final answer. So we know that 24.4 moles of NH3 were used up to produce 12.2 moles of ammonium sulfate. That makes sense? If you guys need a little bit more practice, we're going to do another example of this, and then I'm going to have you guys work it through. So I'm going to write the problem up, pause the video, and then work it through on your own, and then come back at the end and see if you got it right. So let's get into this practice one. All right, so we're going to use our So this is sulfuric acid. This is sodium hydroxide, and we're going to produce sodium sulfate and water in this reaction. And so obviously, if you look, this is not balanced. So this is really easy to balance, guys. 2 here, 2 here. And so that balances our reaction. And now the question is, if we start with 7.5 moles of NaOH, how many moles of Na2SO4 and moles of H2O will be produced. So 2 parts to this one question. Let's get started with the Na2SO4. So pause this here, try to work it through. I'm going to keep going, see if you guys get the right answer in the end. All right. So 7.5 moles NaOH. And if we have our little ratio, we know 2 moles NaOH will produce 1 mole Na2SO4. So we use that ratio, 2 moles NaOH plus 1 mole Na2SO4. This whole unit will cancel, and so we just have to divide by 2. And so we will get 3.75, technically 3.78 with significant figures. 3.8 moles Na2SO4. Just like that. And so let's do that again, but we're going to this time solve for water. So 2 moles NaOH, NaOH will produce 2 moles of H2O. And so 7.5 moles of NaOH, we use our little conversion factor. So 2 moles NaOH will produce 2 moles of H2O. The 2's will cancel. These units will cancel. And so we get 7.5 moles of H2O made. And so there are our 2 final answers to that question. If you guys got it, that's great. There should be extra practice problems up on the Module 8 in Toolbox if you guys want to take a look at those. Otherwise, wait until Wednesday and I'll be handing out a bunch of practice sheets for you guys then. So, good. Here is our first question of the lecture. These are dumb. This is literally just a check to make sure you guys have been watching. So the first question for homework is, what color shirt am I wearing right now? If you give me anything other than purple, I know that you won't or weren't watching the lecture. So on Wednesday, please make sure that you have, for question 1, write the question and write the color of my shirt. And I'll double check to make sure that you guys have it. Please just write it down on like a random sheet of paper or somewhere that I can see that you guys did this ahead of time. So I'm wearing a purple shirt. Please remember that for Wednesday. All right, we're going to move on. So now we are going to talk about limiting reagents. Did everybody get this stuff? You might not be able to see it. Experiment 7 and test 7 are due on Wednesday. So I'm going to erase that. What happened? Can you guys see that? I think so. All right. Give me 1 second. I'm going to grab some paper towel to wipe off this board. I'll be right back. Okay, that didn't help too much. Let's try this. Much better. Okay. All right. Let's get into our big topic for today. We are going to talk about limiting and excess reactants. So, can you, okay, let's try that. Yeah, all right. Limiting and excess reactants. Obviously, you guys know reactants yield products. And so our reactants are what we start with, and our products are what we finish with. And so if we're starting with a bunch of stuff, how much can we finish with? And so that's exactly the practice problem that we just finished, except for we're going to add a little bit of an extra step. So I'm going to give you guys the definition, give you guys an analogy, and then we'll start doing some practice problems with it. So the limiting reactant, also sometimes called the limiting reagent, but we're going to stick with limiting reactant, is the reactant that limits how much product is formed. And then the excess reactant is the reactant with a bunch left over. That is a super not technical definition, but we're going to roll with it. And we're going to use that here. So limiting reactant. What does that really mean? Why are we talking about this? Why is this practical knowledge? So let's say I'm going to use the analogy of getting dressed in the morning. You're looking in your closet. You have 3 pairs of pants and 7 pairs of shirts. That means if one pair or one shirt can only get paired with 1 pair of pants, you can only make 3 outfits, right? You're limited by the number of pants that you have. So you can have all of these extra shirts, but you're only going to make 3 outfits based off of the number of pants that you have. Good? So going into chemistry, if we have 1 mole of reactants and 2 moles, you're limited by the one that only has 1 moles. So I could have 27 million moles of this other stuff, but I'm limited by this one. In the same way, even if I buy extra shirts, I won't make any extra outfits until I add pants. So you're stuck based off of your pants, not your shirts. So 3 pants, 7 shirts, you'll make 3 outfits. Is that a good enough concept to understand? Yeah? If I added 2 extra shirts, so now I have 9 shirts and 3 pairs of pants, I still will only get 3 outfits. However, now let's say I realized I need more pants. And so I go and buy 4 more pairs of pants. So now we have 7 pairs of pants and 7 shirts. Now we can make 7 outfits. If I continue and I buy 2 more pairs of pants, so now I have 9 pants and 7 shirts, suddenly my shirts are the limiting reactant, and we will still only make 7 outfits. So that is the concept, but now we're going to think on the molecule scale. We're not going to think of pants and shirts. We're going to think about actual chemical reactants in actual equations. All right. So we're going to do this based off of, let's see, going to look for a good example. All right, let's do this. So we're using magnesium and HCl, hydrochloric acid to produce magnesium chloride and hydrogen gas. So let's say we have, okay, actually, no, we're going to stop. I'm going to explain here. Based off of our coefficients, it will take 1 mole of magnesium to produce 1 mole of magnesium chloride. It takes 2 moles of HCl to produce 2 moles of magnesium chloride. If everything goes right, that's what will be used. The limiting reactant is not immediately HCl because it's based off of the number of moles that we are given. So far, we don't know the number of moles that we have. We just know the number of moles that it takes, to produce a mole of our product. So we don't know how many moles we have, but we know how many we will need. Now let's say that we are given only 1 mole of magnesium and 1 mole of HCl. We're given 1 mole of each. How many moles of product will be made? So what we're going to do is we're going to go through and look at the number of moles that could be produced just based off of each individual reactant. So we're going to start with magnesium. If we have 1 mole of magnesium, 1 mole magnesium produces 1 mole MgCl2. And so we'll make 1 mole of our product. Right? Good? Now, let's look at HCl. If we're given 1 mole of HCl, only 0.5 moles of magnesium chloride will be produced. And so based off of that, we know that HCl, in this case, is our limiting reagent. Okay, you guys were like, whoa, 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 whoa. How did she do that? Whichever reagent produces less product is your limiting reagent based off of the number of moles that you're given. So if in the scenario we were given 1 mole here and 2 moles of HCl, they would both produce 1 mole of product, and so there wouldn't be a limiting reagent. But now that we don't have enough HCl to produce a full mole of product, HCl is our limiting reagent, and we will have extra magnesium left over. Does that make sense? So the steps of how to figure out which one is your limiting reagent is to go through, make your molar statements like what we've been doing before, figure out based off of the number of moles that you are given, which or how many moles of product are produced by either reagent. Now see which one produces less product. Whichever one produces less is your limiting reagent, and whichever one produces more is your excess reactant. Or have I been saying limiting reagent? It's limiting reactant. They mean the same thing, so my bad. I will try to stick to limiting reactant from here on out. But let's do another practice problem. So I am going to give you guys the problem, pause it, see if you can figure it out, and then I'll do the problem and come back and see if you got the right answer. So let's do this. All right, guys. Um, so antacid tablets. Um, like what is it? Tums? Tums is an antacid tablet. And so what's actually in it is calcium carbonate. And what happens is that neutralizes extra acid. So HCl is your stomach acid. And what ends up being formed is calcium chloride, water, and carbon dioxide. So we've got more than two products, but we're going to take this easy. We're going to be good. So, oh, this is not balanced. There we go. Okay, now it's balanced. So use that. And the question is, all right, that's a long question, but if there are 0.0075 moles of calcium carbonate in the tablet, how many moles of acid is it going to be able to neutralize? So let's say we throw in one acid tablet, you chew it up, you swallow it, it goes into your stomach. Obviously, there's going to be a lot more acid in your stomach than the antacid tablet. And so we kind of just know off the bat that the antacid tablet is the limiting reagent. But the question is, how many moles is it going to be able to neutralize? And so we haven't done this exactly, but see if you can do the math based off of what we've done and using those conversion factors to figure out how many moles of HCl are going to be neutralized. So pause it here, see if you can figure it out. I'm going to work on this. So what's our molar conversion? We look at the coefficient. So we have 1 mole of calcium carbonate, 2 moles of HCl. So 1 mole, 2 moles, that'll be the number of moles it'll react with. So we are going to get 0.0, I should be able to use my head. 0.015 moles of HCl neutralized. Now let's try this and see if we have this many moles of antacid and this many moles of acid plus a bunch of extra, how many moles of CaCl2 will be produced? So 0.0075 moles CaCO3, 1 mole of CaCO3 produces 1 mole CaCl2. So coefficient of 1, coefficient of 1, so we do 1 and 1, and we will produce 0.0075 moles of CaCl2. Just like that. Just for the sake of time, I'm going to skip how many moles of water and carbon dioxide are produced. But if you look at it their coefficients are also all 1. So we know that this math will stay the same. The only thing that'll change is what's being produced. So 0.0075 moles of water and 0.0075 moles of CO2 will also be produced. All right. Now, let's look at, or actually, we'll pause here. Did everybody get that? If you didn't, maybe try watching it fully through again, see if that makes sense. Otherwise, write a little question and I can answer it on Wednesday or shoot me an email, whatever you need. So, all right. Sorry, guys, I'm just looking for the next problem. Okay. All right. Actually, I think this is going to be our last problem for today. I might cut this a little bit shorter than I originally thought I was going to run, but we'll just give you guys a little bit of an extra Thanksgiving break, and we'll do a little bit more on Wednesday when we get back to just kind of catch up and have this be in person. But I wanted to give you guys at least a little bit to start with. So let's do. All right. Yeah, let's do this. Page 10. So this is the question. C4H10O, this is called ether. This is a anesthetic used in a lot of medical procedures. So if a chemist wants to make 134.9 moles of C4H10O, how many moles of C2H6O and H2SO4 is he going to need? So let's just start with this one. If we want to make 134.9, let's just look at our coefficients. So we have 1 mole of C4H10O and 2 moles, that coefficient right here, of C2H6O. That makes sense? So always just put whatever you want to cancel out in the bottom. Use the coefficient that's right in front. Put whatever you want on the top and put that coefficient there too. And so these two units will cancel out just like that. And we'll have 134.9 times 2 moles. It's going to give us 269.8 moles of C2H6O. And so that's how many moles of C2H6O are needed for this reaction. And so now let's see how many moles of H2SO4 are needed. All right, Ask yourself, what would you put on the bottom here? I'm going to put moles C4H10, ooh, H10 on the bottom, and then look at the coefficient, and it's just 1. And then I'm looking for moles of H2SO4, and so I put that on top, and I put that coefficient there. It's just 1. These two units cancel. 134.9 moles of H2SO4. And so we need 134.9 moles of H2SO4 and 269.8 moles C2H6O to produce 134.9 moles of ether. So that's our last practice problem. I'm just going to go through and give you guys a quick little summary of maybe a few things that you might be confused on, and then finishing that out. So, quick question. You guys have probably seen me do this, but you see me cancel out this whole unit, the whole unit of moles of C4H10O, and the whole unit down here. So when you are using moles, make sure that you have 2 units with it. So 1 mole of whatever you want. And so the moles and whatever you want kind of stick together. And so then when we convert it into moles of whatever we're trying to find, that also has 1 mole of whatever we're trying to find. And so the moles of, in this case, H2SO4 kind of stick together. And so then the moles of C4H10O cancel out with the moles of C2H10O. And then we produce moles of H2SO4. Everybody good on that? Yeah, sort of. I might have just confused you more, but when you're writing this out, make sure you're writing moles here, and the compound you want, moles and the compound you want. Keep those 2 units together. The next thing I think you guys might have some questions on are, I guess just like the moles in general that we need. So in this question, we were trying to produce 134.9 moles of ether, and we need 269.8 moles of C2H6O, and we need also 134.9 moles of H2SO4. If you guys just add these 2 mole numbers together, you're gonna get way too many moles, and that's not what ends up happening. So I want you guys to think back to that outfit analogy. 7 shirts, how many did I say? 3 pants only produce 3 outfits. So you're not producing 10 outfits based off of 7 plus 3. They're combining to create 1 product, 1 outfit, and so it's based off of the number that you start with. So 3 pairs of pants produces 3 outfits, not 3 pairs plus 7 produces 10 outfits. So hopefully that helps you guys make sense of where are these moles going. The 2 moles of 2 different chemical products are combining to create a new product. And so we're looking at that through our little outfit analogy. Okay. Oh, last thing you guys might be confused on. You can take moles and find the number of moles for anything else that you would need. So we did one where we had moles of reactant and we found moles of reactants. We had one where we found moles of reactants and we found the products. We had another one where we had moles of products and we found how many reactants we need. It is the same concept for all of them. I know you're like, but what? Always just go back to this molar conversion thing. So If you have reactants and you need to see how many of this other reactant you would need, use moles. If you have reactants and you want to find how much product is made, use moles. If you have product and you need to see how many or how much reactant was needed, use moles. So it's pretty constant, and all you have to do is just change which one you're looking at. And so change that coefficient, but the same concept of being able to cancel it out will stay the same. So that is all I have for you guys. We might do a quick little summary on Wednesday to catch up on this, but here is your last question for, well, I guess, yeah, it'll be due Wednesday. So your second question, that is kind of your check to make sure that you watched this entire video, was, or is going to be, what is your favorite Thanksgiving food that you ate this year? Or just in general. So tell me your favorite Thanksgiving food for question number 2. Mine is mashed potatoes and gravy. So my responses to the questions that I asked are, what color shirt am I wearing? Purple. What's my favorite Thanksgiving food? Mashed potatoes and gravy. And you guys will get full credit for watching this video. So I hope you guys have a really, really excellent break. I will see you on Wednesday, December 4th. Please do not show up on December 2nd. Just don't do it because nobody will be in the classroom. You guys are free to stay home, sleep in, and watch this video whenever you are free. Yeah, so those 2 questions are going to be due on Wednesday. And then also experiment 7.1, that lab workout, and what's last? Oh, test 7 is going to be due on Wednesday. So have a really great break, guys, and I will see you on Wednesday.